Alright, Pierre, I'm going to give you a quick overview of the Saga stuff. So before we get into the code, a few things that might help you along the way. Code's all open source, surprise. It's up on my Stone Age Technologies / cleanarchitecture.net core. You can see the GitHub link here. And it's the code. You can go through it, pick up at the same stuff I'm picking up, download it, walk through the examples. Tests are pretty comprehensive. It is rolled up into a NuGet package, Stone Age Technologies cleanarchitecture.saga, and that's what you will be using. Let's Google what is a Saga. There we go. Sagas is sequence of local transactions. Each transaction updates the database, publishes a message, interacts with an external API. This is really an orchestration layer. It comes from microservices, also comes from domain-driven design. The idea is that effectively we're crafting a transaction. We're in charge of the steps. We're in charge of compensating actions, what happens when a step fails. We're in charge of the flow. Alright, cool. Now let's get into some code. Alright, so let's start with the simple example. Oh, actually, so that's not the simple example. Here's my test. Cool. So there's a few things that happen here. I'm not going to get too much into the steps and task and that kind of thing. Just understand there's a few different ways you can put together this concept. You can kind of isolate things out into their own steps. It's a Saga step, it takes a context, it does something, returns a result, or you can pretty much just inside of the thing here, you could put methods and call local methods inside the with step. You can I've got a lot of different things. Okay, we'll walk through this. This is a great example. So inline actions. So basically the idea is we start off a Saga with a Saga builder. We give it a context. The context is the information that flows through each of those steps. It's carried forward. So you can see we set the context type. In this case, it's just something silly, value 1, value 2. We set the context state. If it's not set, it'll default to empty. You don't have to set state before you start using the Saga. And then it's just a series of with steps and with finish actions. So basically it knows it reaches the end of the Saga. Because we're using this in a use case and there's a presenter, it needs to know what to present back to the user effectively. So the idea here with the inline actions is that it just simply, it's like writing a method. It's just a lambda. So all it does here is just add the two values to result, then it adds 10, and then it corresponds with finishes with the finishing action of returning the test result using the context. I know you could use local variables, Let's keep with the spirit of things, because if you ever want to refactor to some of the other stages, it'll be way easier. Another way of doing this, maybe the way that might be better suited for some of the things you're going after, are to just use local methods. So the idea here is I've got a step just like above. All it does is add the two values. Obviously I need to pass the context through and it finishes. So these first two are identical. In fact, I think all three are actually identical. So those are actions. These are effectively actions being added, which is great if you're not writing any asynchronous code. If you're using asynchronous code, you have a different set of problems on your hand. You need to make a func. Once again, it's a func. It's going to take the context. It's going to return a task. The reason being is the whole Saga engine needs to know to wait for it versus not wait for it. Async, your lambda takes a context. Yeah, I'm kind of forcing things here with a task dot from result. In the real world, you probably have a naturally asynchronous method that's doing this for you, but it's still doing it asynchronously, and it still finishes returning the result. So actually, all three of these are logically equivalent. They're just different ways of approaching the problem. First one's putting everything in line. Next one's kind of refactoring out to methods in my use case. And the last is an example of how to do things asynchronously. And we do have a fourth example here. As you can see, I was kind of playing around and testing. And this one uses steps. So if we want to get to the stage where we feel, if we ever get to the stage where we feel our class is too bloated, there's just too many methods in here, we want to really kind of follow that single responsibility, maybe kind of decouple things a little bit, you can add a step. So what's a step? Well, that's kind of where I started the video. A step's just a little encapsulation of piece of code. It's kind of the next level after doing a lambda or the inline, the in-class methods. It's really just a little snippet of code. It needs to know what kind of context it's returning, what kind of context it's taking, because just like everything else, it's going to be working with the context. And it's really just a way of isolating. If you were to do the steps in production, you'd have to set up your IOC to register the steps so that, well, when you new up the use case, it knows what to take on, what to inject. And that's why I haven't played with it too much. I'm still not quite certain I feel 100% comfortable with that, because there's still some level of coupling there with IOC. But it's a different approach. It definitely is a different way to think about kind of trying to at least break up things and make it more reusable. Maybe that's a better approach. At the end of the day, at least it makes chunks of things reusable without needing to include the whole use case or something crazy like that. So all it's doing is adding the steps as per what was injected and doing the same thing. All of these in the add 2 numbers, then add 10. It's the first example that came to my head. Do the same thing. They're all logically equivalent. They're just different ways of achieving that. So this is all kind of a happy path. Everything's going to work. Happy days kind of thing. The next one's add 2 numbers, then add 10. It throws error. So we've got our Saga without a compensating action, and that's the next concept we'll talk about in just a moment. So basically it's going to add context, it's using steps, and you can see the finish action is a bit different. We've actually not just got a happy path, everything worked, we've also got an error. So there's 2 funcs you can pass here. The first one's the happy path, the second one's the error. Basically you're telling the responder to respond with a success or error message. Someday I'd like to figure out how to just set a responder, set a presenter, and get this to kind of auto magic behind the scenes, but until I have the time, we're kind of stuck with doing the manual 2-func approach. Compensating actions, they're probably the most important part of a Saga. Otherwise, what's the point, right? It's just really a really expensive way to orchestrate methods. So set up the builder, add the context, add our first step, and then what's interesting here is we've got a with on behavior, with error behavior. So the idea being is that we could choose to terminate the Saga at this point. Didn't work. It's going to terminate, jump to the finish actions, and carry on. But in this case, just as an example, I have continue. So it'll continue to the next step, where if there's an error, rollback action on error. This is the compensating action. So what is it supposed to do if this step has a problem? This is where we would normally have put our add 10 step, but in this case, we've deliberately got it to throw an error to test the behavior. The idea here is, well, it's going to actually undo. In fact, I think if I go to the error step, it does add 10 and then throws an error. So it's actually completed its operation when an error happens. So something like, I don't know, you're trying to talk to an external API and it fails. So this idea here is now we're going to roll back the action. We know it's plus minus 10 because we added 10 before, so we're actually going to take the result minus 10 and then present our results back out to the user. The idea here is if we had let's continue and terminate. Terminate would likely jump to the error response and publish the error. I think that's how I implemented it. What's the next example here? Add 2 numbers twice using use case. So we've got an example where we were using an existing use case. Probably a scenario you're going to find yourself in with some of the work you're doing. Set up the builder, set the state, set the steps, and then we've got another step here. And this step is really just the one that demonstrates the use case. It's a little clunky, but at least, because we're allowing you to do inline lambdas, we've got ways of working with things. It was kind of in the back of my head along the way here. So the idea is we've still got to set up the input object. The context isn't going to transfer through. We're going to use a property presenter, so it's going to return a test result or an error. We execute, we check to see if it's an error, in which case we throw an exception, because then the respond with error will kick in. Otherwise, if it's successful, we update the result. And I think the use case in this case is just yeah, it's one of the original. It's the very first one we looked at. A little inceptive, but anyway, so the idea is you can still make use of use cases. You can still, any existing code. I didn't want to make this like something you had to completely gut and refactor your code to. You could take those small steps that are key in refactoring to bringing it in line. Obviously, the whole point here being is, this whole rollback back on action. So if we're refactoring to Sagas, we're going to at some point want to have compensating actions if things don't work. And lastly, yeah, I have a DI with DI. I think I was trying to do something custom here when I wrote this and realized that was a really bad approach. Going into service locator, anti-patterns, and all sorts of fun stuff with the DI. So I hit reverse and left the test, but didn't do anything more than just go, everything has to be registered in the DI to begin with. So idea here is the same, adding two numbers, doing its thing. In this case, rollback on the compensating actions just simply to respond with an error. I don't remember why I was doing that. It seems a bit silly. But I think this add two numbers and then throw exceptions your best bet. The idea being we can stack these. So if I wanted to say, and with error behavior. Oh, I need to put the CTX in. I can compensate. I can terminate and I can compensate. It might make more sense to actually stack this bit of code up like this. Oh, that didn't work out too well. But anyway, the idea being if a step fails, it issues the compensate action. So maybe if it's an external API, it goes and deletes the thing it added. If it's a database call, obviously it's going to roll back and delete what you added to the database. I mean, this is really an alternative to distributed transactions, which are a nightmare, a no-go, just from a performance and scalability standpoint. That's why we started talking about Sagas and doing things this way. So yeah, you can always terminate, you can roll back, terminate, and it won't execute the workflow. It'll finish at that point. So I think those are the big moving parts with regards to this. So like I said, just go find my source code out on GitHub, Stone Age Technology / Clean Architecture -.NET Core. I'm sure at some point I'll bring these into CodeRex because it actually makes more sense. Make everyone a contributor. And maybe sometime for deliberate practice we'll go after some issues in them. Speaking of deliberate practice, I know we haven't done anything for the last few weeks, but I think you've done enough learning around Kafka and everything that we're in an okay place regarding that. So next week we'll probably pick it up again. And the Clean Architecture package is new stoneage.cleanarchitecture.saga. And I've actually got a few downloads. Look at that. That's cool. Yay. I probably have more if I documented everything. So apologies for that. At least I've got some time to record videos and make it all come together there. But yeah, I think that's it. Saga's in a nutshell. Nothing too complicated. If you want to have a little peek at the code, there's the Saga builder. So let's just have a quick look there. It's not a fluent progressive builder, which would mean that at certain stages you only have the options that are available. No, there it is kind of. No, it's not. Okay, I thought the context state was behind its own. I just kept it simple. It's just a fluent builder. rollback action, compensate, rollback on error, compensate function, a whole bunch of methods to add the various types of things. There's a step container. This is basically the thing that runs it. I think naturally everything, is some kind of, it's either, it's invoking it. So it knows, that's the compensation action. Because not only can the various steps be synchronous or asynchronous, the compensating action can also be asynchronous as well. Where's the Saga? Oh, here's the actual Saga that gets produced when you call build on the builder. Where's build? Oh. Hold on. Oh, it's run. Ah, yes, here we go. Here's the thing on the Saga that gets run. Oh yes, because the dot with finish actions are actually the build method. It creates the Saga at that point. So run just goes through each of the steps, catches exceptions, logs them, compensates if needs to, terminates on error if it needs to. If it has any errors, it knows automatically to invoke the error handling. If it has any success, otherwise it invokes the success handling. Like I said, we could probably figure out some way of kind of hiding this with just knowing what the output presenter, what outputs the presenter is expecting. Here's a little wrapper for async to Saga step. And action to step. So just some helper classes, really. So it's not a lot of code, but it does the trick. I spent a good couple of years actually trying to figure out how to make this work with clean architecture in a way that didn't feel weird. I think I was stuck on trying to use it at the use case or compose use cases for too long. And I said, you know what, actually, if we just put a Saga inside a use case and break it out into steps if you want to make reusable logic, life's a lot easier. So it is a rather new concept, but I hope that does the trick. I hope there's enough there to get you going. So good luck, and go team!